So the remaining part of this lecture is a number of clicker questions associated with testing your knowledge of inventory models. So what I would encourage you to do is to go and take the slides that are remaining and see if you know the answer to all of these, and then watch this video and get the answers. Okay, so please, if you have not yet, go see if you can figure out the answers to all the inventory clicker questions at the remaining of this set of slides. This is D6, and then come back and watch this video, and I will walk through the answers. All right, so assuming you've already done this, which I really encourage you to do, the first question is, if you were able to reduce replenishment lead times, how would this impact inventory? Would it impact your order quantity, which it would reduce? Would your safety stock be reduced? Or neither your order quantity nor your safety stock would be reduced, so neither of them, or both of them? So what do you think? All right, so if we're asking about reducing replenishment lead times, in terms of all the notation, that's L. And so if you look at part A, asks about order quantity. So that's Q star. Does L show up in Q star? The answer is no. So it wouldn't reduce your order quantity. So A is not correct. B, if I reduce L, would it reduce your safety stock? And the answer there is yes, because you typically use the square root of L times the standard deviation of lead time per period. So B, yes, safety stock would be reduced if your replenishment lead time would be reduced. So the correct answer is B, not both, because L does nothing to the EOQ, the square root equation. L never shows up. Correct answer is B. All right, so our next question is, if we only care about the holding cost, which of the following would provide the lowest cost solution? So one key thing here is if we're saying only holding costs, what does that mean mathematically? That means we want to minimize the holding cost. So if I wanted to minimize the holding cost, what would I want to do? I would want to order in the smallest units possible, because remember, the holding cost is Q over 2. And so how do I minimize Q over 2? Well, I make Q the smallest it can be. So the correct answer here is D. You should order one at a time. I want to emphasize that that is not the optimal inventory policy, because inventory costs should not just be holding costs. We should also incorporate ordering or setup costs. And so if all we cared about was holding costs, we'd order one at a time. That does not mean that's what we should do, because setup costs S in our EOQ model are positive. And so we want to order Q star that balances these two things. Okay, so our next question is true or false? In the Newsvendor model, the optimal order quantity will always equal the average forecast demand. So another way to say this, in the Newsvendor model, the optimal order quantity will always equal our expected value of demand during the selling period. The answer to this is false, and we actually did an example in the lectures, D5, where you show that we don't always get that we should order the expectation of demand. Instead, we should order based on the critical ratio, so the cost of underage over the cost of overage and underage. And so in the Newsvendor model, because we're again capturing this too much and too little, sometimes we want to order more than we think will happen on average, because to balance the fact that we get a lot of profit from sales, right? And so we want to have extra because sometimes we have more than we expect. But other times we may have less than the average demand. If the cost of overage, if you have a lot left over at the end and that's really expensive, you don't want to do that. And so the correct answer here is false. And instead, you should set how much to order based on this ratio of overage and underage costs. All right, the next question asks, which model balances inventory ordering cost and holding costs? Is it the Newsvendor model, the EOQ model, the safety stock model, or the reorder point? So what model balances these two costs. We can think about the relevant costs. So if we think about the equations of total relevant costs and then we're minimizing them, the EOQ model is the one that minimizes holding cost and ordering cost. And so the total cost is how much do I pay every time I order, plus how much do I pay in holding costs. So the correct answer here is B, the EOQ model. All right, this one is a little wordy, so I'll read it through. A store has set reorder points based on a QR model. Weekly demand is normally distributed with a mean 1,000 and a standard deviation of 200. Lead time is 1.5 weeks exactly. The company wants to move from a 90% cycle service level to a 95% cycle service level. If nothing else changes, will the order quantity Q increase, decrease, stay the same, or depend on the ordering cost? So let's again go back to the Q. In the QR model is set the same way as the EOQ model. And so Q is equal to the square root of 2SD over H. So 2SD over H, none of those input parameters have anything to do with a cycle service level. So if I change 90 to 95, none of those inputs change, and therefore the answer is C, it stays the same. So the order quantity will not change. So C is the correct answer here. If I asked what would happen to R would change. And R is what's balancing the fact that we need to have so much product available. So if I change the cycle service level from 90 to 95%, R would go up. But Q, nothing happens to Q. Okay. All right, one more question. So if D, remember D is demand, is given in yearly units. So we have D as the yearly demand. How many times per year do you place an order in the EOQ model? So the correct answer here is D. It's D over Q. So if you think about D as number of units demanded per year, and Q is how many units per order, then D over Q is how many orders per year. So D is the correct answer. So hopefully all of that you aced. If you didn't, I would use this as a reminder or a trigger to go back through the lectures D1 through D5 and try to understand these phenomena. And so in terms of the final exam, you should be able to do all of these different things. These will be things that show up a lot in the conceptual part, so the multiple choice. And so when I think about you leaving this class, I hope you understand why you hold inventory, what is relevant in the different models, what are each of these models capturing, and so forth. And so you should look through this. As a reminder, all the old exams are posted, and they would be good places to find more clicker quick questions to test your knowledge if you're struggling a little bit with any of these concepts. And please attend our class time on WebEx and our office hours on WebEx if you have questions about any of these or any of these concepts.